The difference between a B and an A star in Cambridge AS and A-level biology? Well, it often comes down to one massive trap hidden inside a topic we all probably think is super simple.
You sit down in the exam, you write out what you think is a perfectly solid definition of the endoplasmic reticulum, and bam, 0 marks. A whole grade boundary literally drops before you even realize what hit you. Okay, let's dive into this, the costly exam mistake, why ordinary revision fails. Why does simply memorizing our textbooks fall so miserably short when it comes to syllabus topic 1.2, the rough and smooth endoplasmic reticulum? Let's look right at the source. According to Cambridge Principal Examiner reports, students are bleeding marks for 3 main reasons. First up, answers are consistently way too vague. Examiners are demanding highly specific structural details. Second, students just forget to double-check their units and exact terminology. And worst of all, their answers are basically just recited from memory rather than being specific to the actual experimental context given in the question. Avoiding these 3 traps is absolutely crucial. It's your first step to securing that A star. Decoding the endoplasmic reticulum, core principles and definitions. To beat the exam, we really have to understand the theoretical architecture here, which requires precise definitions and making logical, evidence-based cross-topic connections. Let's start with the rough ER. Examiners want to see it defined exactly like this: a network of interconnected membranous sacs studded with ribosomes. And notice its core function. It is deeply involved in the synthesis and transport of proteins. Defining these terms precisely before you use them in an extended response is a strict requirement. So please don't just say it has spots and makes things. You've got to use the exact biological terminology. Now contrast that immediately with the smooth ER. This is a membrane-bound network of tubules without ribosomes, and its primary focus is lipid synthesis, metabolism, and detoxification. The principal examiner reports actually reveal a fatal flaw here. Candidates consistently confuse these 2 key terminologies. If you swap proteins for lipids or sacs for tubules, you lose the mark immediately, no exceptions. And this brilliantly illustrates how we need to structure a comparative analysis. To get top marks, we can't just list facts in isolation, right? We must identify similarities, like the fact they are both intricate membranous networks, and we have to highlight the differences, like ribosomes being present versus absent, or protein versus lipid synthesis. You absolutely need to use comparative connectives like whereas or in contrast to, and back them all up with real evidence. So, what is the hidden examiner clue that changes your answer completely? I'll show you in just a second, but first you really need the framework that makes that clue totally obvious. Which brings us to the method mark strategy: deconstruct, solve, evaluate. In Cambridge biology, marks are frequently awarded for your process, meaning your systematic approach is just as important as the final fact. This is the standardized sequence that literally rescues us from writing vague 0-mark answers. Here is our step-by-step problem-solving pipeline. Step 1, deconstruct the question and extract relevant data from the stimulus materials provided. Step 2, select an analytical framework, break the problem into logical steps, and execute it with very clear working. And Step 3, check for reasonableness, evaluate your findings, and justify your conclusions. It forces logical reasoning every single time, pushing us way past superficial memorization. So how do we actually structure this into a high-band exam answer? We follow this exact analytical chain. First, establish the biological concept. Second, pull in evidence or data directly from the exam prompt. Third, apply scientific reasoning to connect that data right back to the concept. And finally, use exact examiner wording to lock in the points. Let's try a quick interactive challenge. Spot the error, flawed versus perfect answers. I'm going to show you a very common student answer, and I want you to spot the exact error using the framework we just covered. Here is the flawed answer. The ER makes things for the cell and moves them around. Take a second and think about it. Based on everything we just discussed about definitions, context, and examiner warnings, why would this score an absolute 0? Now, what's really interesting here is the sheer difference in quality. We have our vague 0-mark answer on one side, but if we act as the examiner's red pen, we get a top-band perfect response. The rough ER synthesizes polypeptides, the ribosomes, transporting them in vesicles, whereas the smooth ER synthesizes lipids. It applies the concept accurately, it uses precise evidence, and it absolutely nails the examiner's wording with perfect comparative connectives.
And hey, don't just take my word for it. This quote is pulled directly from the Cambridge Principal Examiner Report. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. If you memorize the method mark strategy and apply it, you are essentially guaranteeing that you meet their highest criteria, no matter how weird or unusual the exam question seems. The examiner's secret clue: contextual and statistical analysis. Remember that hidden clue I teased earlier? The absolute secret to hitting the top mark band lies in identifying the data or statistical context hidden right inside the stimulus materials. When you're tackling experimental contexts, like, say, an investigation comparing the activity of the smooth ER across different liver cell types, applying the correct statistical analysis is a total game changer. So if you need to compare means, you must recognize the clue to use a t-test. For categorical data, you apply chi-squared. And to find relationships between continuous variables, you rely on correlation tests. Matching the analytical test to the specific biological context proves you aren't just reciting facts. It proves you're thinking like a working scientist. Okay, let's quickly summarize the 3 critical takeaways from this explainer. Number 1, master precise definitions, cleanly separating the anatomical and functional differences between the rough and smooth ER. Number 2, apply the deconstruct, solve, evaluate framework to every single question to guarantee your method marks. And number 3, always identify the correct statistical context to prove your high-level analytical skills to the examiner. But here is the terrifying reality. You now know the perfect framework. You know exactly what the rough and smooth ER do, and you know how to use your data. But what happens when the examiner's command word completely tricks you, pushing you into the wrong mark band entirely? Because if you misread evaluate as describe, all this incredible structural knowledge means absolutely nothing, and your marks will just vanish. This is exactly why you cannot afford to miss our next explainer on Biology 9700, command words that decide the mark band. It is the absolute mandatory next step to secure your grade and protect the knowledge you just built today. Make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Practice those past paper questions, use the method mark strategy, and I will see you in the next explainer.